inverse functions today, and we've got a little idea that we want to remind ourselves of first. This is probably from a long time ago. What is the inverse operation of addition? And I think you guys know that the inverse or the opposite of addition is subtraction. So what happens when those operations are used together? Like if I have x plus 1 minus 1, well, the plus 1 and minus 1, those are inverses. I am left with just the x. They like undo each other. Even if I do it in the opposite way, over to the side here, x minus 1 plus 1. The minus 1 and the plus 1, those are inverses. I'm just left with an x. So we are going to keep that idea with inverse functions. It says the inverse function of f is denoted by this f inverse. It's like f to a negative 1 exponent. It means it's f inverse. F of f inverse of x equals x. It's like your inverses undid each other and you just have the x left, which is the same as what happened up here. And even if you do it in the opposite direction, if I have f inverse of f, again, they undo each other, I just have the x left. Let's see if we can apply this to this problem. Find the inverse function of f of x equals x minus 6, then verify that both f of f inverse of x equals x and f inverse of f of x equals x. So my f of x equals x minus 6, and we know that the inverse or the opposite of minus is plus, so I'm going to call my f inverse of x, make a little guess here. I'm going to say it's x plus 6. And we're going to verify that both f of f inverse of x equals x and f inverse of f of x equals x. So let's start with this one. F is the x minus 6 function, and we have to substitute the inverse in for it. So we have to substitute the entire x plus 6 into the f function. So that means we get, instead of x minus 6, we get the entire f inverse function, which is an x plus 6 minus 6. Now, the parentheses are important if I have anything multiplied in front, which I do not. I really don't need the parentheses. I'm going to erase those. Now I have a plus 6 and a minus 6, which undo each other. I'm down to just plain x. Good. So my f of f inverse of x equals x. Okay, that's a good sign. Now, both have to be true. I'm going to now try to see if the opposite, if f inverse of f of x, let's see if that equals x. That means I have to substitute the entire f of x function into the f inverse function. So instead of x plus 6, I have the entire x minus 6 plus 6. Again, there's nothing multiplied in front of my parentheses, so I can get rid of my parentheses. And I've got another minus 6 plus 6. They undo each other. They are inverses. I'm down to just plain x. Good. F inverse of f of x equals x. So both of these are true. So that means that we found the correct inverse function. Here's our inverse function. Now, it does say in the box here that the domain of f must be equal to the range of f inverse, and the opposite also, the range of f must equal the domain of f inverse. So I'm going to find the domain and range of each. In green here, I've got my f inverse. Its domain is all real numbers. I can plug anything I need in for the x. And the range, because this is a straight line with a slope of 1, this range is also all real numbers. So let's see if that's the case on this f of x function as well. The domain for my f of x is all real numbers. Again, you can plug anything you need in for x. And the range is all real numbers as well, because it is that straight line, which means that the domain of the original function matches the range of the inverse, and also the range of the original function matches the domain of the inverse. So this statement down here is true. We found a correct inverse. Now let's look at the next one here. Show that the functions f of x equals 2x cubed minus 1 and g of x equals the cubed root of x plus 1 over 2 are inverse functions of each other. So if they are inverse functions, then both f of g of x should equal an x, and then g of f of x should also equal an x. We're going to check both. So my f of g of x, the one I have in purple here, means I am substituting the entire g of x function into the f function. So here's my entire g of x function. That whole cube root is going into the f of x function. So I get 2 times, instead of x, I get this whole g function, the whole cube root of x plus 1 over 2. It is all cubed. It was like my x cubed minus 1. So I have a cube root and a cubed exponent. They are inverses. Those totally undo each other. So I'm now at 2 times x plus 1 over 2 minus 1. I've got some more inverses. I'm multiplying by 2 and dividing by 2. So those are inverses. Those undo each other. I'm down to x plus 1 minus 1. And then addition and subtraction are inverses. So this does equal x. Good. My f of g of x equals x. Now, both have to be true. Let's try the other one. This is where I take the entire f of x function and I sub it into the g of x function. So that means the entire 2x cubed minus 1 goes in for the x in the g of x function. So this gives me a whole big cubed root of, instead of x plus 1, I've got the 2x cubed minus 1 plus 1 all over 2. As far as parentheses go in this one, there's nothing multiplied in front of the parentheses, so I will get rid of the parentheses. And then let's see if I can break this down. I've got addition and subtraction, inverses. I've got, plus 1, minus 1. So those are both gone. I'm down to the cube root of 2x cubed over 2. And then 2 over 2 also divides out to a 1. It's like a 1x cubed now. And the cube root of x cubed, inverses, they totally into each other, so this equals an x again. So these are inverse functions. Both f of g of x and g of f of x equal x. And then in the box here it says the graph of an inverse function. If the point AB lies on the graph of f, then the point BA must lie on the graph of f inverse. Let's take a look here. AB, like the A is the x value, turns into your A being a y value on the inverse function. If your B was the y value, the B turns into an x value on the inverse function. Again, they have swapped the x and y's. So it says this means that the graph of f inverse is a reflection of the graph of f over the line y equals x. So we're going to take a look at this and see what happens here. Verify both numerically and graphically that the functions f of x equals 1/2 x minus 5 and g of x equals 2x plus 5 are inverse functions of each other. Let's do this numerically first. We actually did this last time. We are going to do f of g of x to see if that equals x, and we are also going to do the g of f of x to see if that equals x. They both need to equal an x. So my f of g of x, what I have in the middle here is what I just plugged into the f function. So I'm taking this entire 2x plus 5 and I'm subbing it in for the x in my f function, which means I've got 1/2 times, and then my g of x instead of x. So my 2x plus 5, and then you've got a minus 5. Again, I plugged in my g of x function in for x. As far as the parentheses go, there's nothing multiplied in front of these parentheses, so I'm going to get rid of those ones. I still have a plus 5 minus 5, which are inverses. I'm down to 2x times 1/2, and then a half times 2 is 1. I am left with just a 1x. So yes, my f of g inverse equals x. Now both have to be true, so let's try the other one. We're going to do g of f of x. So we are taking the f of x and plugging it into the g function. So the entire 1/2 times x minus 5 is plugged into this g function. So we are going to get 2 times the entire 1/2 x minus 5, and then plus 5. I have 2 times a half. Those undo each other. It's 1 times x minus 5, so just x minus 5, plus 5, and then -5 plus 5 is 0. I'm down to just x again. So yes, they are inverses. Both f of g of x and g of f of x equal x. Okay, so verify both numerically, which we just did, and graphically. So let's take a look at the graph of these functions, and we will see if it is a reflection over the line y equals x. Both of these are straight lines. So let's do the f function first. Let's figure out what f of 1 is. So 1/2 times 1 minus 5 is like 1/2 times -4, and half of -4 is -2. So I get the point 1, -2. Another point that I'm going to get is I'll sub in a -1. Let's see what happens with the -1. 1/2 times -1 minus 5. -1 minus 5 is a -6. So 1/2 of -6 is -3. I subbed in a -1 and I got a -3. So here is my f of x function. The slope of this is 1/2. It's like up 1 over 2. So I can just keep getting more and more points. All right, and I'm going to write a little f of x here just to remind myself which one's which. Next up, I'm going to do the g of x function. So my g of x has a y-intercept at 5. 1, 2, 3, 4, 5. Okay. And the slope is 2. It's a positive 2. So I can go up 2 over 1. I can also go down 2 and to the left by 1 to keep it going here. Here is my g of x. I'm going to label this here. What it says in the box is that you have to have a reflection of the graph of f over the line y equals x. So I'm going to draw the line y equals x. I'm going to make it like a dashed line so we can tell. It's this perfectly diagonal y equals x. And in order to be a reflection over that line, this point 0, 5, if I swap my x and y, should turn into the point 5, 0. Which, let's see, 1, 2, 3, 4, 5, 0. Yes, another point. So maybe this point, -1, 3. If I swap the x and y, I should get the point 3, -1, which here's our point 3, -1. So this is true. It is a reflection over the line y equals x. We've shown graphically and algebraically that this is an inverse function. All right, I hope that's helpful.